Okay, good afternoon. We're evaluating improper integrals, but these improper integrals are different than what we did yesterday because we're looking at, we're integrating over points of discontinuity. Looking at this function, we notice that this function does not exist at x equals 1 or x equal -1 because both of that would make this 0. We don't care about x equals -1 because it's not part of our limit. So we see that when x equals 1, this is a point of discontinuity, so we have to treat this differently. We have to use improper integrals. So what we're going to do is we're going to rewrite this as the limit as b approaches 1 from the left of the integral of dx over the square root of 1 minus x squared. Now, you may have asked, why do I take 1 from the left? Well, the reason I've done 1 from the left is because I'm coming into this integral from 0 to 1. So I'm looking at numbers to the left of 1. Okay, so I'm looking at point 1, point 2, point 3, numbers to the left of 1. So that's why I'm doing it, the limit as it approaches 1 from the left. Now, as you may have already realized, that this just simply gives me sine x. So this is the limit as b approaches 1 from the left of sine inverse of x. Doing a direct substitution, I get the limit as b approaches 1 of, I'm evaluating this from 0 to b, and I should have also written this from 0 to b, sorry. So I'm evaluating this from 0 to b, so it's going to be the limit as b approaches 1 from the left of sine inverse of b minus sine inverse of 0. Now, I can do a direct substitution. If I do a direct substitution and substitute in 1 from the left for b, I get sine inverse of 1 minus sine inverse of 0. And sine inverse of 1 is pi over 2. Sine inverse of 0 is 0. So my final answer is pi over 2. Now, you may be thinking, because I know how you think, well, I would have gotten the same answer even if I hadn't used limits. And that's true, you would have. However, that is not always the case. So you always have to make sure that you are not integrating over points of discontinuity. Anytime you have a rational function and definite limits, you want to just take a moment and make sure that you're not integrating over points of discontinuity. Now, in this case, and in many cases, you will get the same answer, but you still have to check for it, because sometimes you won't. And of course, they like to put those on the AP exam. All right, so this time we see that 0 causes a point of discontinuity. So we're going to do, and I'm going to take it from coming in from the right, because the numbers that I'm looking at are between 0 and 4. So that means I'm looking at numbers to the right of 0. So I'm going to write this as the limit as b approaches 0 from the right, the integral from b to 4 of e to the negative x, square root of x, over the square root of x dx. Now, you may recognize at this point I'm going to have to use a u substitution. So if I allow u to equal to the negative square root of x, then du is equal to -1 over 2 square root of x. So I have square root of dx over square root of x in my problem. I don't have the -1/2. So I have to say -2 du is equal to dx over the square root of x, which I have in my problem. Now, because I have a definite integral, I have to change my limits of integration. So u of 4 is -2. U of 0, or u of b, and since b is equal to, it's the limit as b approaches 0, that still would be 0. okay? But I'm doing the u of b, where b is the limit as b is the limit as b approaches 0. So that still will give me 0. So I have the limit as b approaches 0 from the right of b, and I'm changing that 4 to 2 to negative 2 because of this, e to the u du. And I also have a negative 2 out here. So there's a lot of bookkeeping that I have to keep up with in this problem. But this integration is easy. So this is simply the limit as b approaches 0 from the right of e to the u, negative 2, e to the u, evaluated from b to 2, which gives me the limit as b approaches 0 from the right of negative 2, and I'm going to go ahead and just put that negative 2 on the outside, e squared minus e to the b. Once again, this limit as b approaches 0 is simply going to be e to the 0, because it doesn't matter if I come in from the left or the right, that's going to be 0. So I get my answer is negative 2 e squared minus 1, because e to the 0 is just 1. Once again, it didn't matter that if I had just evaluated this without taking the limit, I would have gotten the same answer. Again, it does not always work, and that's why it's a good idea to check. Let's do one last example. And this time we're integrating from 0 to 2 dx, and we have x minus 1 to the 4th. Now, what are my points of discontinuity for this? My point is x equals 1 is a point of discontinuity. Now, this is a little different because I'm coming from the left and the right to get to 1. So I have to do this one a little different. I have to take the limit as b approaches 1 from the left, and I'm going to integrate this from 0 to b. And I did from the left because when I go from 0 to 1, I'm looking at numbers to the left of 1. And this is dx over x minus 1 to the 4th plus the limit as, let's do a, approaches 1 from the right. And I'm going to look at that from a to 2, and I have dx over x minus 1 to the 4th. Okay, I can do a u substitution here pretty much, but so if I let u equal to x minus 1, then du is equal to dx. So really the only thing I have to do, look at this as u to the 4th. So I'm integrating u, or u to the negative 4, if you will. So I'm integrating u to the negative 4, which would be u to the negative 3 divided by negative 1/3. I'm just doing this on this side just to make it easy so I don't have to do it each time. So I have the limit as b approaches 1 from the left. And integrating this, I get negative 1/3 x minus 1 to the negative 3, and I'm evaluating that from 0 to b, plus the limit as a approaches 1 from the right, and once again I have negative 1/3 x minus 1 to the negative 3, and I'm evaluating that from 0 to a. That's kind of got a little messy there, didn't it? I'm just going to go ahead and erase that. Okay? Alrighty, so integrating this, I get the limit, evaluating this, I get the limit as b approaches 1 from the left of negative 1/3 b minus 1 to the negative 3 minus, I'll go ahead and take out that negative 1/3 so I don't have to write it each time, 0 minus 1 to the negative 3 plus negative 1/3 a minus 1 to the negative 3 minus 0 minus 1 to the negative 3. And again, this is the limit as a approaches 1 from the right. Okay? So, looking at this, I can see I'm just going to do the easy ones first. I have a negative 1/3 on the outside, and it's being multiplied by everything, so I'm just going to take it out of everything. So this will give me negative 1 to the negative 3 is simply just 1. B minus 1, as B approaches 1, B minus 1 is 0. But I have 0 to the negative 3, and 0 to the negative 3 essentially is infinity. Then infinity minus 1 plus, so I pulled out that negative 1/3. So again, I'm going to have 3. If I substitute 1 here, I get 1 to the negative 3, which ends up being 0. And the reason it's 0 because I'm saying 1 over 0 cubed, and I can't divide by 0. So therefore, it's infinity. So this becomes infinity as well, and of course, this is minus 1. So I'm adding infinities together. So because I'm adding infinities together, it just simply goes to infinity. And we see that this diverges. So this time it became important for us to recognize that this was an improper integral. Otherwise, when we just tried to do it on our own, we would have got something weird. So it's important to recognize that this was an improper integral so we could set it up correctly, and we got the answer that it diverges. Okay, so your homework assignment is to finish the textbook work that was assigned yesterday in class or today in class, and we will go over that tomorrow in class as well. All right, have a good evening.